In this problem, we are dealing with a consecutive integer type question with two different types of parameters. So let's read this one. It says, what equation would be used to find the value of three consecutive integers such that twice the smallest is 12 more than the largest? Well, first of all, remember here we're dealing with integers, and what are those? Well, here's the cool symbol for integers. It's like a Z for Zalen or number. And integers include 0, 1, -1, 2, and -2, 3, and -3, and so forth. It's basically whole numbers like 1 and 2 and 3, and their opposites like -1, -2, and -3, and 0. So how do we usually deal with this? Well, the realization is that consecutive integers, whether they're positive or negative, are 1 apart. So for example, we could have three consecutive integers, like, here's an example, 1 and 2 and 3. They're all 1 apart. They're consecutive. Or we can have -1, -2, and -3. These are consecutive because they're 1 apart. So whatever we have here, you're going to take a number as your first number. So x will equal the smallest. And then this is a typical approach for consecutive problems. Then we add 1 to that, and we get the number in the middle. We have three consecutive numbers here, and then we have one more. X plus 2 would equal the largest. And even with negative numbers, -3 would be the smallest. We add 1, get -2. Add 1 to get the largest of -1. Or here, you start with 1. In positives, add 1 to get 2, and add 1 to that, and you get 3. So adding 1 is the way to do it, and typically you might be done by just setting it up so it says x, the smallest, plus the middle, right, plus the largest, x plus 2, equals something. They'll tell you a number. And what you would do then is simplify, add the x's, you get 3x plus 3 equals some number, and solve for x. But that's not what they're saying here. They're not telling you this number, right? They're telling you that, okay, how would you find the value of the integers such that twice the smallest is 12 more than the largest? Well, that means that twice the smallest, x is the smallest, right? X equals the smallest. So twice the smallest would equal 2x. 2x would equal twice the smallest number. So double it. And then well, it means it is or equals 2x equals 12 more than the largest. So 12, right? Oops. We'll take the largest number, which is x plus 2, and add 12 to that. Take 12 more than that, and then that's the balance. So this equation would help you solve this problem because what you have now is x plus 14 equals 2x. And then we're almost done. You can subtract x on both sides, right? You get then what? Well, x equals 14. So you know that the smallest number is 14. And then the next number is, well, one larger, 15. And the next number is 16. And if you're feeling like this doesn't work and you're not sure about it, test it out. Take twice the smallest. So that's 2 times 14, right? Twice the smallest. That's 28. Is what? Is 12 more than the largest. Well, 12 more than 16 is also 28. So they are equal there, which is what it says. These numbers seem to work. And if they ask you a question like this, they might have an extension, which is what is the sum of these three numbers? In that case, you would just add them up, right? 10, 20, 30. 6 and 4 is another 10. That's 40. Plus 5, it's 45. So sometimes they'll give you that sum. And if that's the case, you just add the consecutive numbers like this, set it equal to, in this case, 45, and solve for x. You'll still get x is 14. They might ask you what's the middle or largest number, so be careful. Don't just say 14 is the answer. Be careful. They might, if they ask for that middle number, the answer would be 15. If they ask for the largest number, the answer would be, well, 16, right? 2 plus 14. So just pay attention to these questions and realize that they can add steps to it, but there's still ways to solve it depending on what they give you. Here, in this case, it was just a matter of setting up the equation and then solving for x. All right, thanks a lot.